Hello students. In this session, we are going to discuss the topic alcohols. First, let us discuss the definition of alcohols, how these alcohols differ from phenols, and the classification of these alcohols. See, alcohols are the organic compounds containing an hydroxy group, OH group, where in which the OH group is attached to an aliphatic carbon atom. Phenols also contain an OH group, but in phenols, the OH group is attached to an aromatic carbon, aromatic ring carbon. For example, CH3 CH2OH. Look at this molecule. This contains an hydroxy group. This is an alcohol. Consider this molecule. This is a phenol. See, alcohols also contain an OH group. Phenols also contain an OH group. But in alcohols, the OH group is attached to an aliphatic carbon atom, whereas in phenol, the OH group is attached to an aromatic ring. Okay, now I'll take another example. There is a ring, then we have CH2OH. Look at this molecule. This contains an OH group, but the OH group is not directly attached to the benzene ring. It is attached to a carbon, and that carbon is attached to a benzene ring. So this is not a phenol. This is an alcohol only, because it has a benzyl alcohol. So alcohols also contain OH group. Phenols also contain an OH group. The difference is, in phenol, the OH group is directly linked to the aromatic ring, whereas here the OH is linked to the aliphatic carbon atom. So these alcohols can be classified based on the number of OH groups that are present. These can be classified into monohydric alcohol. Monohydric. So these are the alcohols that contain one OH group. For example, CH3OH. This molecule contains only one OH group, hence this is a monohydric alcohol. This benzyl alcohol is also a monohydric alcohol. This ethanol is also an monohydric alcohol because they contain one OH group. If molecule contain one OH group, then such molecules are called as monohydric alcohols. If the compound contains two OH groups, then such compounds are called as dihydric alcohols. For example, this molecule CH2OH, CH2OH. Look at this molecule. This molecule contains two OH group. If the molecule contains two OH groups, then it is called as a dihydric alcohol. Similarly, we come across trihydric alcohols also. So these are the alcohols that contain three OH groups. Trihydric alcohols. And then polyhydric alcohols. Polyhydric alcohols, these are the molecules that contains four or more OH groups that are linked. Okay. Alcohols that contain one OH group are called as monohydric. If an alcohol contains two OH groups, then it is called as dihydric. If it contains three OH group, it is called as trihydric. If it contains four or more OH group, then it is called as polyhydric alcohol. If you want to give an example of a trihydric alcohol, this can be given. CH2OH, CH2OH, CH2OH. So the name of this molecule is glycerol. Common name is glycerol. So this molecule contains 3 OH group, hence it is a trihydric alcohol. So based on the number of OH groups, we can classify these alcohols into monohydric, dihydric as well as trihydric. Now let us see how these alcohols are named. Okay, IUPAC system of naming is what we are going to discuss now. So hope you know the IUPAC system of naming. Okay, I will take a simple example. CH3 CH2OH. Okay, so in IUPAC system we write the root word, then the functional group is always written as the suffix. So first we write the root word. Root word depends upon the number of carbon atoms that are present in the straight chain. Okay, longest chain. So here in this molecule there are 2 carbon atoms. So hence the root word is eth. There is a carbon-carbon single bond, ethane. Ethane. There is an OH group. OH is a functional group. Functional group is always written as the suffix, and if there is a substituent, it is always written as a prefix. So OH is a functional group, so it should be written after this primary suffix, right? If OH is the functional group, then the suffix used is all. If there are 2 OH group, we use diol. If there are 3 OH groups, we use triol, such things. Now, since there is an OH group, so all, so the terminal E is removed and we write it as all. So the name of this molecule is ethanol. The name of this molecule is ethanol, right? Why eth? Because there are 2 carbon atom. Why all? Because there is an alcoholic group. Okay. If the molecule is like this, CH2OH, CH2OH. Let us see this. Right now, first the number of carbon atom. How many carbon atom? 2 carbon atom. So root word eth. Carbon-carbon single bond, ethane. Ethane. Functional group is OH. OH means all. 2 OH group is there, so it is diol. Diol. Ethane diol. Now, when I say diol, so there are 2 OH groups. You should indicate the position of the OH group. Hence, you should number the carbon chain that you have selected. So our carbon chain contains 2 carbon atoms. I will number it 1, 2. So the numbering is done such that the functional group gets the least possible number. So both carbon contains OH group. If you number it from both the side, you will get the same only. So in first position there is OH. Second position is also there is OH. So ethane 1, 2 diol. Ethane 1, 2 diol. Okay, I will take another example so that we will have a clear picture about this. CH3, CHOH, CH3, CH2OH. First select the longest continuous chain of carbon atom. So the longest continuous chain of carbon atom is 1, 2, 3, 4. This will be the longest continuous chain of carbon atom. See, another option is 1, 2, 3, 4. If I consider this chain, then the carbon carrying the functional group will not be included. Whenever you select a chain, the chain selected should be such that the functional group carbon should be included in the chain. Functional group carbon means this carbon which carries the functional group and this carbon carrying the functional group should be in the chain. So this is only one possibility that we can have. We cannot select this chain 1, 2, 3, 4. This chain we cannot select. If I select this chain, then this carbon carrying the OH will not be included. It should be included. Such a way you should select a chain. So there are 4 carbon atoms. Hence bute. Carbon-carbon single bond, butane. 2 OH groups, diol. Butane diol. Let us try to number it. Okay. So numbering should be such that the functional group carbon gets the least possible number. Okay. Here there are 2 carbon that carries a functional group. If I number it from this side, functional group carbon will get 1. If I number it from this side, it will get 2. So from here only it is getting the least number. So hence 1, 2, 3, 4. If there are two functional groups, similar functional groups, then you can take the sum of those rules, sum of those numbers. Locants is what we call. So this carbon gets first number, this carbon gets third. So 1 plus 3 is 4 here. If I number it from this side, so this carbon will get second number, this carbon will get fourth. So 2 plus 4 is 6. So this is the best way of naming. So butane 1 comma 3, 1 comma 3 diol. Okay, there is a methyl group remaining. So that is a substituent. That should be always written as a prefix. So it is methyl butane. So where the methyl is present on the second carbon. So hence it is 2-methyl butane 1,3 diol. 2-methyl butane 1,3 diol. So this is how we name the diols. I mean compounds containing the 2 OH groups. Now, if the compound contains 3 OH groups, same method should be used, but instead of using the diols, we use triols. Triols is what you should do. If there are 3 OH groups, triols. Okay. Now, so what are alcohols? Alcohols are the compounds that contains hydroxy group, OH group, that is attached to an aliphatic carbon atom. Whereas phenols, how they do differ from the phenols? In phenols, the OH group is attached to an aromatic ring. And that aromatic, if you consider a benzene ring, then the carbon hybridization of that carbon is sp2. Whereas here the hybridization of the carbon is sp3. Right? So if a alcohol molecule contains one OH group, it is called as monohydric. If there are two OH groups, it is called as dihydric. If there are 3, we call it as trihydric. If there are 4 or more, then we call it as polyhydric alcohols. Okay. Now let us see the preparation of this glycol. Glycol, I mean, if there are 2 OH groups, we call them as glycols. If the 2 OH groups are on the adjacent carbon, that is terminal carbons, we call them as glycols. So 2 OH groups, generally we call them as glycols. So ethylene glycol, we call this as an ethylene glycol. Okay, this molecule is referred as the common system of naming. This molecule is referred as an ethylene glycol. Ethylene glycol. Let us see the preparation of this glycol, ethylene glycol, from ethene. Okay, how we prepare this ethylene glycol is what we are going to discuss. Okay. Let us see the preparation of ethylene glycol. Okay, let us see how this ethylene glycol is generally prepared. Now, from ethene. So, ethene contains CH2 double bond CH2. I want to prepare ethylene glycol from this. Ethylene glycol means I want to prepare CH2. This molecule is what I want to prepare. Okay. So this is ethene. This is ethene. This is ethylene glycol. Ethylene glycol. I want to prepare this ethylene glycol from ethene. If you want to prepare ethylene glycol to ethylene glycol from ethene, ethene contains a double bond and this contains a single bond. So you need to convert double bond into a single bond. If you want to convert double bond into a single bond, always we carry out addition across this double bond. So if there is a carbon-carbon double bond, if you want to convert that carbon-carbon double bond into a single bond, then addition across the double bond should take place. So the addition reaction will convert a double bond into a single bond. So if you want to convert ethene to ethylene glycol, that means you need to convert a double bond into a single bond. That means you should carry out addition across this double bond. So now addition of what? See, since we want glycols, then we need to add OH across this double bond. So 2 OH groups is what you should want. You can do this in a single step as well as you can do it in a 2-step also. Let us see the first method. In the first method, okay, if ethene gas is passed through cold dilute alkaline potassium permanganate solution, if you pass ethene gas through cold dilute alkaline KMnO4 solution, hydroxylation takes place. The reaction is also referred as hydroxylation reaction. So hydroxylation reaction is nothing but the addition of OH group takes place. Okay. For example, if you take this ethene, if you take ethene, CH2 double bond CH2, if you treat it with alkaline KMnO4, dilute solution, then what happens is across this double bond OH group adds up. Okay, so OH group adds up, so you end up in getting this compound CH2 single bond CH2 OH OH. So across the double bond OH group adds up. So this reaction is also referred as hydroxylation reaction. Okay, whenever ethene is treated with alkaline KMnO4, dilute solution of alkaline KMnO4, okay, addition of OH groups across the carbon-carbon double bond takes place. Okay, addition of OH group across the carbon-carbon. So this is also referred as hydroxylation reactions. So this is what happens in a single step. Even ethylene glycol can be prepared by treating ethene gas. Ethene is gaseous in nature. Ethene gas with hypochlorous acid. And in next step, then addition of water is what you should do. We'll just go through that reaction also. Now, the second method. In this method, what you can do is this ethene gas is treated with hypochlorous acid, HOCl. Ethene gas is treated with hypochlorous acid, that is HOCl. So addition takes place across the carbon-carbon double bond. When addition takes place, the double bond gets converted into a single bond. OH adds up to one carbon, Cl adds up to another carbon. So you get this compound. So when addition takes place, double bond gets converted to single bond. So OH adds to one carbon to another carbon, addition of Cl takes place. This is what happens. This is called as ethylene chlorohydrin. This is called as chlorohydrin. Chloro because there is a chloro group, hydrin because there is an OH. CH2 is called as ethylene. So this is called as ethylene chlorohydrin. And this is what you are going to get. So in the next step, this ethylene chlorohydrin is hydrolyzed using sodium bicarbonate solution. The ethylene chlorohydrin, see what we want this ethylene glycol is what we want. We want this ethylene glycol. So we have one OH here. So here in a single step, addition of OH across the double bond takes place. Hence you get a product in single step only. But here addition of OH and addition of Cl takes place. So you have one OH here. So what we want this Cl to be replaced by OH. We want that Cl to be replaced by OH. If you want that Cl to be replaced by OH, then hydrolysis is what you should carry out. See what happens now. This ethylene chlorohydrin, that means CH2 OHCl is subjected to hydrolysis. Slightly it is heated in presence of sodium bicarbonate. See, when you treat it with sodium bicarbonate solution, when you hydrolyze it using sodium bicarbonate solution, what happens is here? So this Cl gets replaced by OH. Water can be considered as a source of OH. The whole water molecule adds up, and then hydrogen proton gets released from there. So addition, what happens is OH replaces this Cl. So you get this compound CH2, CH2, OH, OH. The Cl that has been released combines with the H plus of this and forms HCl. So whatever the HCl that is released gets neutralized by this sodium bicarbonate solution. Okay, so this is what happens. So here what we have done is, in this reaction we have added 2 OH group in one step only, hydroxylation by using alkaline KMnO4. Here we have added 1 OH group in one step and second OH group in second step. So this is a two-step reaction, whereas this is a one-step reaction. So in both the reactions, what we have obtained? We have obtained ethylene glycol. So this is how ethylene glycol is prepared. This is how ethylene glycol is prepared. Okay. So we got an idea regarding the preparation of ethylene glycol. Okay. So this was about alcohols. Okay. The classification of alcohols into primary, secondary, monohydric, dihydric as well as trihydric based on the OH groups, and then preparation of ethylene glycol from ethene. Okay, ethylene glycol from ethene. So this is hydroxylation reaction, and this is the reaction with HOCl, that is hypochlorous acid, followed by the hydrolysis. Okay, thank you.